Now let's define the length of the tangent for the circle. So now that we have defined the tangent for a circle, let's see what exactly is the length of tangent we define in the mathematical sense. Now suppose I take a circle S equal to 0. Now for this circle, if I have a point P x1 y1 which is outside, then and if I draw a tangent through P, where this cuts here at A, then in this case the point P x1 y1 through which I draw the tangent makes some length with the circle. So this length from point P to the point of contact of the tangent is called the length of tangent. Now here A is called the point of contact because this is the point where the tangent makes contact with the circle. So A is point of contact, and therefore length of tangent with respect to circle S equal to 0, and if suppose I have this x1 y1 is length of tangent is AP and it is given by root S11 is the formula I have for length of tangent. So length of tangent from the circle is PA and it is root S11. So now that we have discussed about position of a point, similarly we discuss about position of a straight line with respect to the circle, as we have there with three cases with a point lying inside the circle, on the circle or outside the circle. Similarly, a circle has three different cases when we discuss about position of a straight line with respect to the circle S equal to 0. So let's discuss the three cases where a line L cuts the circle S equal to 0, then it cuts making two distinct points P and Q. So one is the possibility that a line cuts the circle, one is the possibility that a line touches the circle, this, and one is the case where a line does not pass through the circle. So when a line cuts the circle, it has 2 points of intersection. When a line touches the circle, it has 1 point of contact, and when a line does not cut the circle, there is no point of intersection. This is how we understand between three cases: case 1 cutting the circle, case 2 touching the circle, and case 3 does not meet the circle. Now let's see what will be the mathematical conditions for each of the three cases where a line cuts the circle, touches the circle, and does not meet the circle. So if I take the radius of the circle as r, and if I take the center of the circle here, then each of the circle with same radius r, then let me say the perpendicular distance from center to the line is P, is small p, and the perpendicular distance from center to the line is P, and the perpendicular distance from center to the line is P. Then I say P is perpendicular distance from center to line L, that is center of the circle to the line L. Now, as I have in three different cases where the perpendicular distance from center to the line is P here, and this P is here, and this P is here, then I see that if the perpendicular distance of this is less than radius, then I get case 1, because clearly I see that the radius is extended till down, but perpendicular distance is only till here, so P is obviously less than R. P less than R. So this is the case for a line cutting the circle at 2 points. Similarly, for here, I have clearly P is equal to the radius because radius itself is the perpendicular distance. So when a line touches the circle, the perpendicular distance is equal to the radius is the case for the second case of line touching a circle. Now as I see that P is greater than the radius which ends only till here, that is the radius is only till here and P is still here. So clearly P is greater than R. Therefore, when P is greater than R, the line does not meet the circle. When P is equal to R, the line meets the circle, and when P is less than R, the line intersects the circle. This is how we understand the three different cases, connecting the radius with the perpendicular distance from center to the line. Now let's see the equations of tangents for the circle in various different properties. Now say I have a circle passing through origin and having radius R. That is, equation of this circle is x square plus y square equal to r square, because center is origin and radius is r. So for this circle x square plus y square equal to r square, let me draw a tangent somewhere here. Now let me say this is the tangent for the circle which has slope m. So the tangent has the slope m. Now for a line which is a tangent to the circle with slope m, for the circle x square plus y square equal to r square, equation of tangent is given by the formula y equals mx plus or minus r times root of 1 plus m square. Is how we get. Now plus or minus gives us two tangents, because if I have a tangent here, now when two lines are parallel, the slopes are equal. Therefore, there is another line which is equal, exactly parallel out here. When this is a line which is parallel to this, and therefore this also has slope m. There is a possibility that there are two lines, there are two tangents for a circle which are parallel to each other, this being parallel to this on the other side of the circle, and therefore the slope of this will also be m. Therefore equation of tangent t and t dash will be given by this, one with plus and one with minus. Hence there are two equations out here, one given by plus and one given by minus. So when I have a tangent whose slope is known, then for this circle with center origin and radius r, I can find the equation of tangent where m is slope and r is radius. This radius of circle, and this is slope of t. This is how we understand the formulae connected with finding equations of tangents. Now let's see the equation of tangent where the circle is not in the standard form. What if the circle is in general form? What if the center of the circle is not origin? Also, we need to derive the equation of tangent. So let's see for a general equation of circle how we can find the equation of tangent respectively. So I have a circle whose equation is given by s equals 0. Now I have a tangent at here whose slope is given to be m. The slope of the tangent is m is what we have. Therefore, equation of tangent t whose slope is m is given by y plus f is equal to m times x plus g plus or minus r root 1 plus m squared. Now here r is the radius of circle and f and g we know are from standard equation x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So r is radius of circle which is given by root of g squared plus f squared minus c. We know this from the formula. And m is slope of tangent t. Is how we understand the formula for equation of tangent with slope m. One is plus, the other on the opposite side is given with t dash. These two lines being parallel has the same slope. So therefore equation of t and t dash are given by this. The two lines parallel to each other and the tangents for the circle S equal to 0 are given by this equals this plus or minus of r times this. R is the radius and m is the slope. Now let's take the concept condition for existence. When do we say that a line is a tangent to the circle or is not a tangent to the circle is the biggest question of the topic. So we need to identify on whether a line is a tangent to the circle or is not a tangent to the circle, which comes under condition for existence. What is the essentiality for a line to be a tangent to the circle? So let's see out here. When I have a circle, when I have a tangent at point P, x1, y1 with the circle equation being s equal to 0 in general form, then we know that the center is minus g minus f from here. Now condition for a line to be a tangent to the circle is that radius must be equal to perpendicular distance from center of circle to the line is what we conclude. If this is equal to this, then we say then the whole of this perpendicular distance will give us the condition. If radius is not equal to this, then the line is not a tangent to the circle. If radius is greater than perpendicular distance, then we say the line is outside the circle, does not meet the circle. If radius is less than perpendicular distance from this, then we say the line is non-intersecting. But if radius is greater than perpendicular distance, then we say the line is intersecting or cuts the circle at 2 points. We have taken this in the previous 3 cases, but now the condition for existence of a tangent is that radius must be equal to perpendicular distance from center of circle to the line T. Now if I take the equation of tangent in general form as ax plus by plus c equal to 0 as the general equation of line this T, then ax plus by plus c, then I have the radius which is given by root of g squared plus f squared minus c. We all know that radius is calculated from the circle s equal to 0, where s is x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Therefore, radius for this circle is root g squared plus f squared minus c, which must be equal to perpendicular distance from center to the line. That is mod ax plus by plus c by root of a square plus b square is how I understand the property of this connected with this. So condition for existence of a tangent to the line is that this must be equal to this, where this is the line and this is the center of the circle for the standard or the general equation of circle being this. Now let's see the condition for existence of a tangent for a standard form of a circle. That is, if I have a circle with center, origin and radius r, then what is the condition for the line y is equal to mx plus c to be a tangent to the circle is what we discuss. So the condition here is that c must be equal to plus or minus r root 1 plus m square, where r is radius of circle and m is slope of line t. Is how we understand the condition for this line to be a tangent to the circle x square plus y square equal to r square, center, origin and radius r. The condition is c equals plus or minus r root 1 plus m square. So if c is equal to this, then we can say that the line y is equal to mx plus c is a tangent to the circle x square plus y square equal to r square. Condition for existence of a tangent to the circle in standard form. So let's see how we can find the equation of secant for the circle. Say for example, I have a circle S equals 0 and here is a secant which cuts at 2 points P x1 y1 and at Q x2 y2. If the line L cuts the circle at points x1 y1 and x2 y2, then this line is called the secant. So we know that PQ is the secant for the circle S equal to 0. Therefore, the formula for equation of secant PQ is given by S1 plus S2 equals S1 2. This is how we understand the equation of secant for the line for the circle S equals 0. Now that we have defined the equation of secant, we will derive for equation of tangent in the similar manner. Now say for example, I have a circle S equal to 0 and I have a tangent T at the point P x1 y1. Then equation of tangent at point of contact P x1 y1 is given by equation of tangent P at P x1 y1 with respect to the circle S equal to 0 is S1 equals 0. So when I want to find equation of tangent at P with respect to the circle S equal to 0, it is S1 equal to 0. We know that S1 is xx1 plus yy1 plus g times x plus x1 plus f times y plus y1 plus c equal to 0 is the equation of tangent for a circle S equal to 0. So if I have a standard form of circle, say a circle with center as origin and radius as r, then the equation of tangent at p x1 y1 for the standard circle x square plus y square equal to r square is given by equation of tangent at p x1 y1 with respect to the circle. This is given by xx1 plus yy1 minus r square equals 0 is how we have. Now this is again derived from S1, because if I assume this to be S, it's again the S1 which we have identified. So S1 equal to 0 is the base of understanding the equation of tangent for the circle S equal to 0. Now let's understand the topic of finding the point of contact. How do we find the point of contact which the line makes with the circle, that is at the point where the tangent meets the circle? So for example, I have the problem which says find the point of contact which the line 4x minus 3y plus 7 equal to 0 makes with the circle x square plus y square minus 6x plus 4y minus 12 equal to 0. So the question here is to find the point of contact which this line is making with this circle. So let's see how we can find the point of contact. So as I clearly see that it is given that the circle is x square plus y square minus 6x plus 4y minus 12 equal to 0, and the tangent line T is given to be 4x minus 3y plus 7 equal to 0. So as I see here, I don't have the point of contact. Because I want to find the point of contact, I say let p x1 y1 be the point of contact of T with S, that is the line T with the circle S. Therefore, if I have a circle S equal to 0 and the tangent T at which the point of contact is p x1 y1, the line is already given to be 4x minus 3y plus 7 equal to 0. Therefore, with the line given, now let's find the equation of tangent for this circle S equal to 0. Now we know that equation of tangent T at p x1 y1 with respect to the circle S equal to 0 is given to be S1 equal to 0, which we know through the formula. So using this S1 equal to 0, that implies we have S, which is x1 plus yy1 minus half of minus 6, which is minus 3 of x plus x1 plus half of this 2 times y plus y1. This, on further simplification, gives us the equation of tangent in terms of x1, y1.